Welcome to EDU World Space.
So we're continuing on with reactivity of the nonmetals. This podcast is mainly focused around some different chemical calculations that we can perform. So in the first one, we have the formation of FeTiH2 that is given in the following reaction. That is FeTi at H2 that is in equilibrium with FeTiH2. So the amount of FeTi is 100 kilograms, or 1 times 10 to the positive 5 grams in SI units, and the molar mass is 103.7, where 1 mole is equal to 103.7 grams. So the number of moles of FeTi is 964.3 moles. So the number of moles of FeTi reacting is 964.3 from the stoichiometry of the reaction, where 1 FeTi corresponds to 1 H2. Therefore, H2, because we have a 1-to-1 ratio, we have 964.3 moles here as well. So because we know equivalent statement is 1 mole of H2 is 2 grams. So therefore, we have 1929 grams of H2, 1929 grams of H2 that is stored in FeTiH2. Next, we're looking for the number of moles of hydrogen that are calculated in the reaction, where we have 964.3 moles at standard temperature pressure. So recall our ideal gas equation, which is PV equals nRT. Rearrange for volume, V is nRT over P. We can plug in our values here, where we have 964.3 moles multiplied by 0.0821 moles per Kelvin per litre per atmosphere, multiplied by 273 Kelvin divided by 1 atmosphere. We get a volume of 21.61 times 10 to the 3 litres. So moving on to the final part, so the amount of hydrogen that has combusted in air to produce water is 21.61 times 10 to the power 3 litres, which is what we just looked at. The reaction for the combustion of hydrogen in air, we have H2 add 1 over 2 O2 is in equilibrium with H2O, that is water. So the standard enthalpy of formation of water, that is negative 483.6 kilojoules for 2 moles of water. So the moles of hydrogen that is present, we have 21.61 times 10 to the 3 litres of water, that is 964.3 moles. So with respect to this reaction above, there is only 1 mole of water produced using our stoichiometric ratio, where we have 1 H2, half O2 and 1 H2O. So what we take is 964.3 moles multiplied by negative 483.6 kilojoules divided by 2 moles is 2.33 times 10 to the positive 5 kilojoules. And so the energy produced of combustion of water is 2.33 times 10 to the power 5 kilojoules.